In the state of Kansas, agriculture is king. Along with high yields of corn and soybeans, Kansas is the top wheat-producing state in the U.S., with yields of more than 382 million bushels in 2012, according to the USDA. The secret to this land's bounty is not just the soil that covers it, but also something below ground that no one can see: the Ogallala Aquifer, the largest freshwater aquifer in North America.
For decades, you've had incredible production of agricultural crops on top of this, and largely that's because of the incredible water resources that have been available to it.
The Ogallala Aquifer, also known as the High Plains Aquifer, is a groundwater storage reservoir that stretches 174,000 square miles underneath parts of 8 states, from South Dakota to Texas.
This well here is 303 foot deep.
Stan Townsend, a 6th-generation farmer from Weston, Kansas, grows corn, wheat, pinto beans, and peas on his land. Like many farmers, Townsend depends on the aquifer to irrigate his crops, especially during times of extreme drought.
This country is about weather, and right now it's sure not in our favor.
Today's irrigation technology is able to pump out water that has been in the aquifer for hundreds of thousands of years in just a matter of minutes, a rate which far outpaces how fast nature can replenish it, threatening the overall sustainability of the aquifer and agriculture.
This well over on the southwest was right at a 2,000 gallon minute well, and now all we're getting out is about 600.
According to the Kansas Geological Survey, groundwater levels in the aquifer have dropped an average of 14 feet since 1996, about a foot a year. Aquifer drop rates suddenly doubled, an average of 2 feet a year between the start of 2011 and the end of 2012 alone.
Since about 2011, there's been a significant drought, and this is really across most of the High Plains Aquifer, but this area, as well as others, you're now in a period of extreme to exceptional drought.
Dave Hyndman, a hydrologist at Michigan State University, is leading a team of scientists funded by the National Science Foundation that is studying the aquifer. The team is analyzing data from as far back as the 1800s on changes in climate, irrigation technology, and water policy to build models that could forecast what the future holds for the aquifer and for farming.
When we feed the climate into these models, we're able to predict what happens with the water levels. And as long as we have pumping data, we really get a great understanding of the system.
One of the reasons why the aquifer replenishes or recharges so slowly is due to the water cycle itself. When precipitation in the form of rain or snow hits the ground, some of it runs off. Some evaporates back into the air from the ground, or is transpiration from plants. What doesn't run off or evaporate slowly seeps down through the soil and its layers by gravity in a process called percolation. In western Kansas, it can take 1 year to recharge the aquifer by less than an inch.
There's not enough recharge out here, not enough precipitation.
During the drought of 2012, Mitchell Ballman, a 4th-generation farmer outside of Hoxie, Kansas, was able to maintain his crop yields only by pumping more water out of the aquifer.
In 2012, we were drastically impacted. I mean, it affected our crops, definitely affected the aquifer. We depend heavily on the Ogallala, which is what we're pumping up for our pivot irrigation.